Now, sometimes it can be a little ambiguous, and what that means is that even using the law of sines, you don't always know what triangle it's going to be. There's a little bit of a confusing situation. The situation comes up with that second point, that SSA. So if we know two sides and an angle, this is a side-side angle situation where the two sides are like we have two sides connected and then an angle not in between them. So the first thing we got is a situation where A is acute. And remember, acute doesn't just mean adorable, it means it's less than 90 degrees. There are four situations. If the A value is less than the height, then there's no triangle that exists. So like looking at this length right here can't connect to that bottom length. There's no possible way. Now the other option is if A is equal to the height, well then it just forms the triangle there. If A is between the length of the height and the length of the other side B, then it could be a triangle that goes like this, or it could be a triangle that goes out here. So there's two different options. And the final one, if your A value is larger than your B value, then, well, we just have one triangle. That's the easiest situation. The other type is if A is a right angle or it's obtuse. Right angle, remember that means 90 degrees. Obtuse means greater than 90 degrees. Now, if the A is a right angle or it's obtuse and A is less than B, the A is not going to be able to connect to that third side. It's going to be too short. You're not going to be able to form a triangle. Now, if the A value is larger than the B value, you'll be able to form exactly one triangle. So when you're solving a triangle and you're given two sides and an angle, the angle not between them, the first things you got to do, you got to figure out the values of A, B, and the measure of angle A to determine the number of possible triangles. If there's only one triangle, we get to use the law of sines. Now, if there are two triangles, that's where it becomes tricky. That's where we're going to focus on the honors in the next section. We're going to use the law of sines to both find two different angles, possible angle B or B sub 1 and B sub 2. Again, we'll worry about that if you're in honors. So let's take a look at an example. We're asked to determine the number of triangle banners that can be formed by using the measurements A equals 50, I'm assuming this is in inches, or maybe centimeters, B equals 20 inches or centimeters, and measure of angle A is 28. So we're dealing with an acute angle here. So A is greater than B. So going back to that, A is greater than B, so we have, thankfully, only one triangle we need to worry about. So A greater than B, we got one triangle, and I'm going to use some mathematical symbols. Therefore, again, just getting fancy, dot, dot, dot equals therefore. I don't know why I wrote that out the shorthand and then just wrote out the longhand, whatever. So, therefore, there's only one triangle. Ooh, sorry, that's a highlighter. So let's start drawing out a triangle, and it doesn't matter how you draw it. I'm just going to draw one that looks like this, and I'm going to start at the top here. There's angle A, there's angle B. Actually, scratch that. I'm going to put angle B down here, and angle C there, and therefore this is going to be side length A, this is going to be side length B, and this is going to be side length C. The information that we're given, we know that angle A is 28 degrees. We know side length A is 50. And we know side length B is 20. So now we have enough information to use the law of sines. So we have side A and angle A. So that's going to be one of our angles we're going to go to. So we're going to do the sine of angle A over side length A. And since we know side length B, let's find angle B while we're at it. So side length B, we know, well, we'll use sine of B over side length B. Plug it in what we know. Angle A was 28, so we got the sine of 28 degrees divided by side length A, which is 50, equals sine of B. We don't know B yet. We're going to have to work on that. Divided by the side length B. Now, we could go through and cross multiply and divide. One shorter way, if we know we're going to want this part all by itself, let's just multiply both sides by 20. Now, on that left side, it's going to get a little messy. I'm going to say it's 20 times the sine of 28 degrees over 50 equals the sine of angle B. Now I'm leaving that left side alone because I don't want to have to type that in until I have to. I don't want to type it in, get a number, have to round it, and then we're going to have to plug it back in. Now remember, we're trying to get angle B by itself, so what we're going to need to do to undo sine, as we looked at in section 10.4, we have to take the inverse sine on both sides. Now thank goodness for calculators. So on our calculator, we can type this in exactly as it is. Now I'm going to say this inverse sine, and on your calculator, open up parentheses. And I'm going to say put your whole numerator in parentheses, 20 times the sine of 28 degrees, divided by 50. And after we clean up all that stuff, that's going to give us angle B. So we type that in, and B, after we type that in, ends up giving us an angle measure of 10.8 degrees. So let's add that to our triangle. We got 10.8 degrees. Now, since we have two of our angles already, let's find our third angle. Measure of angle C is just going to be 180 minus those other two angles, so minus 28 minus 10.8. So it's going to be about 141.2 degrees. So measure angle C. Now, one thing you might notice, and especially if you have me in class, you'll notice I rarely draw things to scale. And that's okay. As long as we're labeling things properly, not going to be a big deal. So the last thing we got to do is we got to find measure of side length C. Again, since we were given angle A and side length A, let's use those. So I'm just going to kind of jump or cut to the chase there. So we're going to do the sine of 28 degrees, so that's angle A, over side length A, equals, we're trying to find side C, so we're going to put that in our denominator, and it's going to be the sine of angle C. Well, angle C is 141.2. This one, since the value that we're trying to find is in our denominator, I would suggest cross multiplying. So we have C times the sine of 28 equals 50 times, let me zoom in on this, I'm running out of space, the sine of 141.2. Ooh, goodness gracious. Now, to solve, I don't know why it's not letting me write. To solve for C, we're going to have to divide both sides by the sine of 28 degrees. And again, making sure we type this into our calculator as either two separate lines where we do that numerator first and then divide that by the denominator, or putting that numerator in parentheses, we end up with C equals about 66.7, well, whatever unit we're dealing with here. So now our final side length is 66.7. And we've now completely solved the triangle.